Hello, hello. So we're moving from backend architecture to frontend with Antoni. Enjoy.
Hello. Um, Let me play the presentation. Okay, welcome to this talk about service workers. My name is Antoni, and usually I spend my days here as a front-end engineer for Team Pau. This is the agenda of this talk. More or less, we are going to discuss some terminology, what are the challenges, why caching matters, what's a service worker, and some cool stuff. So, first of all, the beginning. Raise your hand if you know what is a progressive web app. Okay, a progressive web app could have a really long definition of why it's great, but at the end it all boils down to one desire. We want to make a website as good as a native app on any device. We want to make it available offline, we want to make it fast, and we want that the users can just access to it via the home screen, via an icon. So let's take a look to what's a web page or just a web app. It's just simply an HTML document that has links to other documents such as images, videos, or music, whatever you want to show to your users, and also some references to JavaScript, CSS, or any kind of piece of code that tells your browser how you want to show your page and how you should interact with it. So each one of those lines that we have seen is a request. So the browser reads first the HTML and thinks, oh, I need more stuff. So let's take a look to the journey of one request. This journey is going to happen only inside our browser. When you open a web page and a request is made, the first thing that you hit is the memory cache. It's like an instance of all your resources in memory for the current domain. It dies when you close the tab or you close the browser, or sometimes even the assets can die even earlier. If you didn't find your asset into your memory cache, the next step to look into it would be the HTTP cache. This is a cache that we can influence as developers. We can say, I want this resource to have a match age of X time, or even to be a new player is to be immutable. I say to the browser, I'm never ever going to change this resource. But here things start to become expensive. You have to access the disk, you have to perform some heuristics, and to know really if you should get this cache fresh from the network, but this asset fresh from the network, or if it's good, the one that you have cached already. And we also have new players with the new protocol HTTP2. One of the cool stuff that you can do is start sending to the browser assets that you know the web page is going to need and you want to preload them, but even before the first request is made. So it's a kind of lost and found box for assets. And if none of those cache mechanisms succeed, you can go to the network and, well, this is an absolutely different story outside your browser. So this brings us to the next term. Who is familiar with Li-Fi? No one? I think all of you are. Have you ever been in a public space, such as an airport, and you go, oh, free Wi-Fi, I'm going to connect. And then you open whatever and you get this? Well, the Wi-Fi is a lie. You were promised with internet, but you got nothing. And this brings us to the first UX concern. When we got all these tablets and cell phones and small screen devices, we had to start thinking mobile first. So try to shrink our layout and our information and put it in the minimum space. But now we have to also think about what's happening offline. Because if you leave your users with nothing, is the worst information that they can have, is the worst experience. So we have to start thinking offline first. Let's take a look to what's a service worker. A service worker is mainly a piece of JavaScript that allows you to intercept the network and change the response. Is event-driven. We are going to see in a bit the events that responds to. Is registered against an origin, so your domain, and can intercept and modify any kind of request that you make. Is not blocking. It runs in another thread in your browser, so the rendering will perform nice. Is designed to be fully async and has access to other cache mechanisms such as IndexedDB. Remember, if you want to use them, you must be under HTTPS to avoid man-in-the-middle attacks and security concerns. Doesn't have access to the DOM because it's not its task. And also, if there is something that you are trying to do that is synchronous, it will fail. It won't have access to it because it's designed to be asynchronous. Also, for privacy, if you open a private tab on Firefox, you won't have access to this technology because they could track you. So, if you remember the journey of our request, in which place would the service worker fall? Just here, which is the most performant part, because just after the memory cache, you can decide if an asset of your website is not found, what do you want to do with this? Usually, you can cache information in two ways. If your piece of information is an asset behind a URL, such an image, you have a cache storage. It's a new technology that you can just put the URL and the asset that you got from the network. And it fits something that looks like more structured data, such as the state of your application or private user information. You got really, it's well supported everywhere. Is IndexedDB called this technology. It's just a small database in your browser. So let's demo a bit why this is great. To do this, I faked a fast but crappy 3G network with some random delay and a long round trip. And I went to our single sign-on webpage. And what we see here is that the browser knows that many core assets that are required to show this page are necessary to fetch before the first meaningful paint. So there's going to be over 3G about 10 seconds before we can really show something, which is kind of bad. Let's take a look to what happens the first time the user loads and there is a service worker behind it. Well, mainly the load of the page is absolutely the same, but then the service worker kicks in when the first render and of the page happened, so it won't interfere with whatever you are doing, and start caching everything that is necessary to show this page offline, or whatever you decide that is necessary. So the next time when the user loads this page, the first meaningful paint happens after a bit more than half a second. And after a second later, we see that another network request is being made. The browser itself tries always to get the freshest version of the service worker. So if you have a new cache strategy, you will delete old stuff here and get the new things. How would your first service worker look like? Well, service workers has a life cycle. It's a piece of JavaScript that you first try to install under your domain. If this succeeds, or you decide that succeeds, it gets activated, and from this moment, every time that a fetch or a request is made by your browser, you will get into the fetch event, and you can decide what to do with it. So we are reaching the live demo part of this talk, why this is really cool. So first, I guess I should introduce the demo app, which is going to be this one. It's a really normal website. It could be an application with some charts and a really cool cheat. It has some sections like a book section to do whatever with books, and games, and some news about grumpy cats, and whatever content that you decide to show. Can you read? Is it the screen clear for everyone? gonna try to make it a bit bigger. Blah, 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 blah. And to clean everything. For the purpose of this demo, we also have a great Node.js server that every time that we load something is going to tell us what are you trying to request and makes it to the server. So let's go back to the presentation. First of all, granularity. Whenever you want to cache something, a key aspect is granularity. When you have your website, you want to be able to update only the fonts or only the JS or only some of the assets without having to download everything again. So a good way to go is decide, okay, I have all those are my core assets, and I want the service worker to be installed only if I'm sure that I have those assets cached and they are available offline. So for instance, if in our example, we enable the service worker and we say, okay, the static files that I need to run this website are those, and I put here something that doesn't exist. When I reload this page and I go here in Service Workers tab, and there is an asset that cannot be found, the installation of the service worker will fail. This is to prevent that you have a cached version of your website that cannot work. So if we comment this part and we upgrade the version of our cache, what will happen is that the browser will detect this new version, and after downloading all the assets that you need for this page to be cached, the service worker installation is going to succeed, and you're going to have the service worker installed. Let me show you also what's happening on the server, because until now, every time we load the page, we were requesting everything. But now that the service worker is installed, if we reload the page, we only get one request, which is the service worker itself to detect if a new version is available. Okay, this is quite basic. Now if we go into the network and we fake that we are offline, this page is already working. Great, this is what we wanted. Let's move on. Share the cache. Imagine that you have different teams taking care of different aspects of your application, such as we have here, someone is dedicated to books and someone is dedicated to games. Would not be nice that I can benefit from something that already someone cached for me? Well, you can do it. You can decide that you have your service worker managed by the team that manages the books, using and caching information that is only meaningful for whatever the books section needs. But when I don't have this in resource on my cache, I can ask the other service worker or the other cache if it has this resource for me. So you can split also responsibilities, which usually is great. We like these things. Another great thing is a generic fallback. What happens when you get a 404 error? Usually what we would get is a dinosaur or a sad phase of your browser, or just a 404. But you can intercept this event and reply with whatever. So for instance, if I would type a non-existing URL, such as this one, instead of getting a 404 message, I can just reply with a generic fallback. Okay, the request was for HTML. Let's reply with an HTML that says, okay, I really don't know what happened. You seem to be offline. Bring me back home. Bring me back to a place that I know. But what would happen for other resources? Like for this image. If our page is requesting an image which the source is absolutely crazy, like this one, the generic fallback could also kick in and tell the user you are offline, or what you are requesting I don't know what it is. So you would not break the design, you would not break the layout of your page, and you could still show something meaningful. I cannot load this for you, sorry, but maybe when you are online it will be there. Let the user choose. This is quite important. Really heavy strategy or heavy caching strategy could lead you to put too much information of your website into the device storage. So if everyone does this, what's going to happen is that one day your mobile is going to say, you don't have more storage. Do you want to delete everything? And all the cache that you had is going to go away. So the best is to let the user say, I like this, make this available offline. And the other benefit is that you learn about what this user specifically likes, so you can get better suggestion. An example of this could be in the news. If you say, okay, I want to make this available offline, this event would request to the server whatever you need to show this page offline. So if we go here to the network and we say, okay, you are offline, and we reload, the page is still there, the article is still there, but since the moment that the user says, okay, I don't want this anymore, the cache for this is going to be deleted, the space is freed, and for instance, now we are offline. If I reload this page, I will get the generic fallback. So you could just go back to your page, or some website like The Guardian, what they do when you read all the news that you have cached, you are offline, is they should say, we don't have any news for you, but you can just play some games like crosswords or something like this. You can always entertain your user. Let's see more stuff. The service worker can play good with other cache strategies that you have in place. Like, for instance, imagine you have already a great HTTP cache strategy. You could make that after your first load of the service worker, whatever the service worker needs to load from the network, it could be provided already with by this cache. So you don't need to download twice the same image that you want to make available offline. But it could be also the other case that you want to bypass these cache strategies. Then what you would do, there is a native way of doing it, but it's not well supported yet. So what, let me go online again. What I particularly do, and most of the people, is say, okay, I need resources. I want to make sure that they are available and that I bypass any cache. So I just put a cache busting strategy, just simple extra parameter with a random unique number. So it will bypass any cache system of your browser and go to the network and make it to the server. You could also do all the cool stuff, like we know that this part can be slow or really slow, and maybe the asset that I want to load is really small as well, are some bytes. So I could say I raise the network. I make a request to the cache and I make a request to the network, and whoever wins, the first that comes, I'm gonna get this response and put it on the browser if it's not a 404 or no errors happened. So this is a bit the overview of things that I wanted to show. Thank you a lot for listening. I don't know if it was clear enough, but I'm gonna know it in the Q&A. And I wanted to thank also Margie for the great designs she provided for this presentation. So there are questions.
Anybody? Cool.
Are we using this currently?
We are testing it in the SSO, in the page. There is a proof of concept there. You can find it, and I'm gonna put the code available somewhere in a Git repository and the slides as well. But the idea that the main benefit that we could have with this is make our users aware of when something goes wrong, like when our systems are down, almost never, or when there is a problem, make them aware that this is not going to work, and also free our servers to having to deliver a lot of resources that we can decide when is the time to load them.
Should you inform the user that they are reading like offline content?
Yeah. Yeah. Yeah, via UX, you need to tell always what's happening. Like, you seem to be offline, but I have something for you. When you get back online, you will be able to do more stuff, or we will see what happens. But this is, let's say, your power. Sorry?
For the user, it's a new way of interacting with the web page.
Yeah, for a web page, but those look more like a native apps, and you already have these on mobile apps. Like when you are in a tunnel or just in airplane mode, you can do on some of them some stuff, and some of them say, sorry, you are offline. So you get the same behavior.
Yes, I had a question about the differences between the progressive apps and this. And the other is, so exactly, we have to let the user choose if he wants this functionality or not, because not all browsers would also support it, right? Only recent versions.
Yeah.
So it's like we detect which browser version it is, if it supports it, and then we let the user choose if he wants it or not.
Yeah, so first question, what is supporting this? Mainly Chrome, Firefox, so Android mobile is supporting this. The people from Apple didn't like it much because it's a way to write applications for iPhones bypassing the Apple Store, so it's under consideration for the next 4 years. And Microsoft is implementing it under the operating system layer even, not the browser. So you will get cool ways to interact with this.
How does this, what's the difference between progressive apps and this? Because
so a progressive web app is it's a set of technologies that allow us to write websites that behave exactly the same as a native app, and ServiceWorkers is the part that helps you and allows you to make it available offline. So when you don't have network connectivity, you can still show content. Before, we just had the dinosaur of Chrome.
I'm a bit curious, have you read anything about battery life implications for this? Since after the request is finished, you're doing extra processing.
Yeah, so a service worker is usually, is often killed and is only awakened when your application tries to make a network request. The installation event only happens the first time and is more network intense than CPU intense. In terms that at the beginning it's true that you go to through a list of assets that you decide to cache and you download them. So maybe you are downloading actually more stuff than you need to just see what you are seeing now. But then in terms of battery life, it's really well optimized. So when you write one service worker, you also have to keep in mind that whatever variable that you wrote outside your event is not going to be visible because got killed. So your scope is only in your event. You have to define in it whatever you need.
Yeah, if you are going to cache all your resources for offline access, isn't it even more important than to have your resources optimized in size? Because we now generally just serve one asset, high res, nice for desktop, and the browser will decrease the size on the phone. But if it's going to be kept forever in some kind of cache, then it is actually taking up a lot of space.
Yeah, and also for granularity, it makes sense to split your resources in the smallest amount that you can. So HTTP2, it's meant to improve these things, but what most of the people is using now is like a bundled first load and then let the service worker just granularly pick what you want. And on the second reload, you will get just these assets load immediately, but in a granular way. So the first load is still a big chunk because it's more optimal by the network, but The second load is just a cached set of things that you can granularly update when you decide.
Thank you very much, Antoni.
Thanks for coming.